I am Eric. I am a long-time open source developer, previously for Apache with big data analytics frameworks, and after for Jupyter. I worked on a lot of different aspects at Jupyter, while JupyterLab, Jupyter Server, collaboration, and so on. And so based on those experience at Apache and Jupyter, I came to try to add value for the data analyst. And it was not that easy always to do that in the open source repository or in the official RIP organization. So I created my own company called Datalayer, which is a startup. And we try to add value for Jupyter user. We try to do that in the open. And for example, we allow any Jupyter client like JupyterLab or VS Code or CLI to add GPU, runtimes or kernel, whatever name you give, without changing anything in your code. This is an example. Another example is that we add AI capacity to JupyterLab, to VS Code also. And so today I'd like to discuss a bit, or to introduce you to the MCP server we have been working on, which is part of the global ecosystem in the AI world. So this is what we're going to see today, a bit of what is MCP. And MCP has been specified 1 year ago by Anthropic, so exactly 1 year ago in November last year. So I think right now it's a bit well established or well known. But still, I think it's good to review that, go after into the details of the Jupyter MCP server, do a few demo, and then expand a bit the picture to more the AI areas and the enterprise aspects. So this is the kind of elevator pitch you can find online, where you can see MCP being compared, or like being compared, yes, to like a USB bus. So a USB extender where you're going to plug and play your different device. In this case, the device are more like some services, like some Google Drive or Gmail or Slack. And the consumer of those devices or services are not the laptop in our case, but more an MCP client, but maybe something to chat like a cloud desktop or a VS Code. Well, personally, I don't like so much that picture, so I prefer this kind of diagram where we like box like the different components, and this is before MCP. And what you can see, you have an agent, and typically an agent is like a system which is going to manage like a LLM. LLM is more like a closed box. You know what it is a bit. That's not the topic. And to open the LLM to the outside world, like to the internet or to some services like Slack or Google Drive or GitHub, what you had to do 1 year ago is to implement some embedded tools in the agent. So if you're using LangChain to develop your agent, you implement embedded tools. And if you move to another framework, you re-implement again. So this is one pain. This is not the biggest pain to me. The biggest pain is really the diversity and non-stability of the external API, because you as developer of the agent, you need to deal with those API. You need to know how to speak to Slack or to speak to Google Drive. So this is really the pain and the issue that the MCP protocol solves. And because you know that in IT software, every issue can be solved by yet another layer of abstraction or indirection, this is exactly what MCP is offering. It's a protocol, it's a layer, or it's a way to ease the pain for the agent. So on the right diagram, what you see is the agent, which doesn't have to speak many languages. It doesn't have to speak Slack or Google. It just speaks MCP. And the second point is that the agent offloads or push back the responsibility of the interactions with Slack and so on to the outside world or to a third party. So if you develop an agent with MCP, you are not more obliged to carry on the GitHub API. You just kick off an MCP server for GitHub, and it's going to work. So when we saw all those chat and MCP server, we thought, hey, how can we ease the access to some Jupyter server so that as a chat or prompter, you can interact in live with a notebook. And this is the right lane where we developed the Jupyter MCP server. And from the start, we decided to do like in a very flexible and scalable way, meaning that we are not tied to the local host or to your Jupyter server extension, but every piece of the puzzle or the chain here can be deployed in separated hosts, local, remote, cluster, or whatever. Including the Jupyter server, which in a way managed the notebook model, right? The IPyNB, which is a notebook, and the kernel. So all those two entities can run on separated server. And our Jupyter MCP server handles that for you. So I'm going to say begins this year or March. We started very easy. We said we're going to open a repo. We're going to have like a one file MCP server with the official MCP toolkit and a few tools like insert cell, run cell, and so on. And then we started people coming and giving likes, posting about that, blog posting on Hugging Face, on YouTube, or whatever. And we receive contribution a lot. So yeah, it kind of grew quite nicely. And just to give you an idea of the kind of feature we ramped up those last months. Initially, we only supported one notebook, and people were asking, hey, I want like many notebooks, so we added multi-notebook support. Initially, we were not giving back the answer of the execution. Now we give it back, and the LLM can do something more clever. Recently, we implemented like some JupyterLab as commands as tools. I will detail that a bit later. So the repository is under Datalayer organization, Jupyter MCP Server. We have quite some docs, and happy to reply on any issue you would open. Right, so before giving a demo, I'd like just to show you again two architecture diagram. I hope you can follow me with those boxes. So this one just shows, hey, to benefit from what you're going to see at the demo, you need to run Jupyter MCP Server in the middle. You need a MCP client typically embedded in a chat application, whatever it is. And upstream, you have your local Jupyter, and this communicates with RTC, real-time collaboration, even if it's local. Or you can run on JupyterLab if you are enterprise, or you can run on any other system. It's all standard Jupyter protocols. But at some point, we said, well, you still need to launch two servers. So the user, especially the Jupyter notebooks, likes to be fast and easy. And we said, OK, we're going to make it easier. And we're going to merge, in a way, the Jupyter MCP server with the Jupyter server. So the two above layers, you just have now one only. And how we do that, we expose the MCP protocol as a Jupyter server extension. It allows the user just to install the package and launch JupyterLab, for example. When I say server, I mean lab also. And because the MCP server is now a Jupyter extension, it's going to allow to serve protocol of MCP, which is like hey, gRPC with request response, and it works. Let's go to the demo. So I'm going to skip ahead a bit because just this one shows you how to create the Conda environment, to install the needed libraries. So I think I can move on and go maybe show you quickly the command to launch, which is like the JupyterLab with a few parameters. We say, hey, it's local and so on. You give the kernel, maybe the place where the kernel, the node runs, and an additional parameter you need is to configure, in this case, Cloud Desktop, and you need to say, hey, Cloud Desktop, this is MCP server, I want you to run, but this is typical activity, and Cloud Desktop will show the tools provided by the Jupyter MCP server. From there, you can prompt, and in this case, we're going to ask, hey, analyze the cell CSV, do a summary, do a plot, and then do a forecast. So, well, here we can see the tools in, well, the LLM in action, invoking the tools. Hey, I'm going to use notebook. I'm going to list the files before. I'm going to insert, execute a code cell. And this is hands-off, right? So it does its own way. And then you see it fails because Pandas is not installed in the environment we just created, but it's going to recover because it knows it failed. So you see the last one is execute code. It's not execute insert or insert execute, it's just execute. So we have a tool just to run some code on the kernel. And then it's going to continue to provide you the plot you expect and the forecast you expect. And let's leave it do its job. And this is available, let's say, if you run on JupyterLab, the notebook will be on JupyterLab also. Okay, but yeah, it's going to create the forecast, and we are done. Okay. The tools you have seen are like this basic one, which has still, we kind of iterated based on user feedback because, well, sometimes if you give many tools, you get less good results. So it's always a trade-off. But this has been done with, I'm going to say the user. So you have mainly the insert, execute, read cell, override, execute, and so on. This tool is a bit different. We added recently a tool which actually comes from another sister repository which we call Jupyter MCP tools. So JupyterLab has that concept of commands. While if you go to the JupyterLab palette, you have the list of commands, just like Visual Studio Code has some commands. So what we have done is implementing a way to discover all those commands, the core JupyterLab commands, but also the commands of the potential extensions, JupyterLab extensions you install. So that Jupyter MCP tools is going to discover those commands, and is going to expose them as MCP tool with the correct parameter, with a description, and so on. So once this is available, on the other side, the MCP server can say, hey, I want to use or give me the list of tools I can, and these are very visual tools. For example, open a dialog box, or open a debugger, open a notebook, run all the cells, or whatever. And the Jupyter MCP server is going to request the list of tools. Maybe it's going to choose based on some config you're going to give. And those tools are now available for you from your chat box. So this is what we call commands as tools, and it's quite recent. Right. And moving forward, we want to make it even easier for you, for the user. So we said, hey, we add that Jupyter AI agents repository, yet a third one. And roughly 1 year ago, we started that 1 year ago. And what it was a CLI with a LangChain agent with embedded tools, which was also doing some interaction with the notebook. So from the CLI, you were prompting and asking to do something, just like you showed, and the notebook would be created. We had also another kind of agent or feature, which was like explain error. So from the CLI, with that repository, you could also explain the error of a notebook if there was an error, and the LLM would insert the cell, fix the cell, and so on. And we said, hey, we're going to expand a bit more that repository, and what we're going to do, we're going to add a UI, which are going to use the MCP server, embedded one, and which, as a server extension, and the MCP tool. So it's also quite recent, I think 1 or 2 weeks ago, we had a push to ship that chat box, integrated with the Jupyter MCP server. Right, so you have this sidebar. It's not the only one, but I'm going to review a bit, or compare why we did that. And before, let me show you also a quick demo of that. Well, nothing very magical. You've already seen that. You install, you launch, okay, with the correct parameter, and then you prompt. I could have prompted the same way as the previous demo. Here we're going to prompt in a bit different, and yeah, quite fun fact, sometimes if you don't say, well, this is a list of tools, right, which are available. You can activate or disable them. Here we say create a Panda notebooks. We don't say create and run a Panda notebook, so the LLM is just going to create it without executing the cells, right? It's going to insert the cells. So this is a tool invocation of the MCP server, just one process. And then we say, okay, you need to execute the cell. And I think it's going to just execute cell 1. The first one is going to be executed. So yes, it is. But yeah, you get the idea. So I took the freedom to compare a bit what we have, comparing the other open source systems. There are other open source which do similar things, right? There are closed source also. And I think all those systems are finally going to converge with the same feature sets. They will be able to add MCP server on the fly, based on the configs. They will be able to invoke the tools and so on and so forth. I think our stack and how we approach the system is that we are, I think, the only one to be able to deploy that in a quite distributed way. So the server, the model which is moved to the server, the notebook model, the IPyNB, lives on the server, the kernel lives somewhere else. So all that is distributed. It's not sandboxes. So we don't see the world as you need to go to JupyterLab. It can be from VS Code. We have a Datalayer extension for VS Code, which is going to benefit from all those features, where you're going to spin your kernel to the right, your notebook going to live to the left, and your MCP server going to be, I don't know where. And your UI can be anything you want, which support MCP. Right, so I think for the enterprise there are, some interesting aspects to be discussed, where you can deploy separately. We support JupyterLab again, and what we're doing also, this is a fourth repository today I mentioned, is the MCP Server Composer, because those MCP servers are quite, you need to secure them, you need to observe them, you need to manage them, configure them. So at some point, we had the requirement, we had like another Earth data MCP server, which pulls data from NASA, and you can think like a Conda MCP server to create an environment. So all those MCP servers needs to collaborate together. And potentially, you will have tools named clash, they don't know each other, and so on and so forth. So we have an activity around what we call a composer, where a kind of bundle of MCP server, which can be observed, managed, and secured with authentication and authorization. So this is a work in progress. But MCP server, the Jupyter needs to discuss with many other aspects like GitHub and so on. So coming a bit like to the last slide, but I think for us this is just the beginning of the story. MCP received strong push in terms of specifications. There are some new features coming regularly. So prompts was over there. Elicitation is one new feature, sampling, root, and so on. All those features which are specified are optional, but we want to bake them into the MCP, our implementation. And so the first bullet is approved. The second one is still being discussed, and it is about long-running operations. Because if you run a cell, you say, OK, I'm going to kick off execute cell with a tool, and the cell maybe is going to take, like, I don't know, 5 minutes, or depends. I mean, 2 minutes, but 2 minutes for waiting the response and having your chat being blocked is not OK. It's not OK. To overcome that, we have that long-running operations where it's like async, I'm going to say. You have async task, and you're going to have an ID, and you can be notified when the task is completed. It's not yet approved at all, so maybe in 2 weeks, maybe in 2 months, I don't know, but we follow that, and we will implement that feature so that as a user, you can launch and have a view on your long-running tasks. And so maybe you're going to say, well, the kernel anyway is busy, fine, but maybe you're going to chat with another notebook, with another kernel, whatever. You're going to have maybe multiple kernel because we support that on a single notebook. So it still makes sense to have that async task. And then we also have security, management, observability, evals, and so on. We can bake that into tools or feature, whatever. So this is something like still a lot of work to be done. So yeah, growing, happy to discuss on GitHub, on the conference. And with that, I really thank you. I wish you